Okay, this is Homer Part 2. I have no idea why the program crashed. It's back up and running. Everything looks fine. I reloaded all the data in because I didn't save the project. Let's do that now. Okay, save as. I'm going to put it in my Dropbox, 426, make a new folder called Homer Files. And I'll call it Tutorial 01. Okay, so now if it crashes, I haven't lost anything. So where we were last time, we were checking out the solution. We had, the DMAP, some specifications here. Let's just take a little time more looking at this. So here's the levelized cost of energy, 73 cents a kilowatt hour. So that's looking at amortizing the cost of the unit over the 30-year life. Just kind of same kind of thing we do with the screening curves. Cost $22,000 a year to run this. There's a lot of information here that we can look at, but this is kind of neat, this plot. So this is showing, you can go day to day, right? Here's January 1st, January 7th. You can kind of just look at the load, and basically the load and the generation is the same because there's only one source. You can kind of look at it on a monthly sort of basis to show how it changes. But here's the load duration curve. So we saw this. Let me blow that up a little bit. Look at that. So you can see it looks like the load duration curves we saw before. Here it goes 11. It's not as flat as the ones we saw for the residential loads, and then comes back down here to 0 there. So kind of neat. You can play around with it a little bit. Here's a cumulative density function, which comes from here. In other words, the load that was most often seen was about 2 kilowatts. So yeah, so let's keep going here and see what's happening. That's that. Simulation results. So let's take it one more step, and then we'll wrap up this part of it. So remember the search space window? That's this little grid up here. Let's give it more options. And specifically, let's say, hey, you know what? There was an 11 kilowatt load, so let's give it a 12 kilowatt option here. So lots of possibilities here. And so what it's going to do is going to say, oh, you know what? I bet a 12 kilowatt generator will work best. And it does. Now what you get there, if you size it just right, in other words, now you don't have a lot of excess capacity, you get a lower cost of energy, 64 cents a kilowatt hour instead of 72. And you look this up and you get the same kind of information we had before. It just costs a lot less up front. So yeah, we'll call that good. What I want you to do next is go into the Getting Started guide, and it follows through an example similar to this one, but also has a wind turbine on it, and shows you how to put in a wind turbine and specify a wind resource. So go ahead and work through that and get those results and start getting a feel for this. And over the weekend, I will post another video where we discuss the we'll walk through a wind installation as well, but we'll do it for the Boise area and kind of see what that looks like, and start having some more fun with this. So that's it. This is what I've posted for Thursday. So go ahead and do this. Make sure you can get this done and get into the Getting Started guide and run through that and go through that tutorial all the way up to, but not including, the sensitivity analysis. So go as far as we got from here, which is to do an optimization. Since now they've got wind turbines and diesel generators, you'll have more opportunities, you'll have many different viable options, and you'll explore that. And if you have any problems, send me an email and we'll talk about it. Thanks a lot.